Good morning and once again welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamoto. And today I want us to understand further coordinate geometry in XY plane, and we continue to discuss subtopic using trigonometric identities. And to help us, we are going to understand example 4 on page 22 of this book, Pure Mathematics 4, Pearson and Excel International A Level, Pure Mathematics 4, student book, and page 22. And in that question, we are saying that a curve is defined by the parametric equations as shown below. X is equals to sine t and y is equal to sine 2t, where t is all the way from negative pi over 2 to pi over 2. And the first part of the question expects us to find the Cartesian equation of the curve in the form y is equals to fx. Of course, with y ranging from boundaries negative k all the way to k, and of course stating the value of the constant k. Part B of the question is write down the range of fx. In other words, establish the value of y, the limits of the value of y. We might be expected to sketch a graph to answer part B, but let's see. Now, when we have y is equals to sine 2t, this one, it goes without saying that the sine 2t is not well defined here, so we might not express sine 2t in terms of x, and therefore we might be forced to look for something that can easily describe sine 2t that will bring us closer home. And we're going to use a trigonometric identity, and we're going to say we know that sine 2t is equals to 2 sine t cos t. This one is a known trigonometric identity. In our previous video, we have discussed this in Pure Mathematics 3. You can search it in my YouTube channel, Pearson and Excel International Maths by Mr. Kamoto, and you'll find it there. Having said that, it is again very important to note, as much as we can be able to express sine 2t in terms of 2 sine t cos sine t, it is again important to realize that y can be expressed in terms of 2 sine t, but sine t is equals to x. So we can substitute y is equals to 2 sine t cosine t to form 2x, because sine t itself is x, and multiply by the cosine of t. Having said that, yes, we have been able to eliminate the sine t and substitute it with x, and now we are remaining with this part, because the main objective of this approach is to do away with t, parametric variable, and bringing the xy Cartesians, so that we are able to express our curve in terms of y is equals to fx. And of course, we have known before with the very primary trigonometric identity that sine squared t plus the cosine squared t giving us 1. Of course, from this, we can make the cosine of t, the subject of the formula, to be the root of 1 minus the sine squared of t. And having said that, we know that the sine t is x, so this one basically is the root of 1 minus x squared. So easily we can now find and say our y is equals to 2x multiplied by the cosine of t, which incidentally is the root of 1 minus x squared. And that is just the Cartesian equation that we are expected to now to realize, which is realized. But in the same question, stating the value of k, and we need now to state the value of k. And of course, we are not going to just push away the t, because for us to get the k, we must consider the lowest value of t and the highest value of t, because they are the ones that are going to simply make us realize the lowest value of k and the highest value of k. We had these limits of t when our parametric equation were in terms of t. So we should have these limits of x when our equation is in terms of x. And therefore, when t was minus pi over 2, it is important to note that x is equals to the sine of minus pi over 2, which is the sine of negative pi over 2, and we have something to do with negative 1. And when t was positive pi over 2, then x become sine pi over 2, and we are substituting x in this original setup, which is easily 1. So if we need now to rearrange our equation in terms of x and the range of x, we're going to say y is equals to 2x, the root of 1 minus x squared, where x ranges from negative 1 all the way to positive 1, both limits inclusive. So our value of k is just 1, because we are comparing this with this. Our k is simply 1. And that is part A of the question. Part B of the question is asking us to write down the range of fx. And the range of fx is simply the value of y. When we talk about the range of fx, the value of y, it becomes a bit interesting, because we must now consider y was originally the sine of 2t, and you can see you can see what our y has become. So you may choose to use this and probably sketch a graph with x with various values of x, starting from 0, minus a half, minus a 1, and all the way to 0, a half. And okay, we'll do this on this particular part. And for now, let us discuss something. When x is when t is equals to minus pi over 2, of course, y is equals to sine of 2t sine of minus pi. That one is simply going to be the sine of negative pi. It might simply be 0. It's going to be 0. So it might not be very good in giving us the range. So we need to sketch the graph of the same when x is 0, when t, this is t pi over 2, and then we can talk about pi, we can talk about this is negative pi over 2. We can also talk about positive pi. When t is pi over 2, we need to consider one thing. Because the sketch of the graph of y is equal to sine 2t, we can even have pi over 4. Let's enlarge the range, because is going to be pi over 2, and we can even go now to minus pi all the way. Pi over 2, we can go to positive pi. So when t is minus pi over 4 sine 2t becomes minus pi over 2. So when we're talking about the sign of minus pi divide by 2 close bracket, you get -1. When t is pi over 4 minus pi over 4, then you get a -1 there. When t is minus pi over 2, so 2t is minus pi. So we're talking about the sign of minus pi. And you close the bracket, you'll find this is going to be 0. So the same case when t is pi over 4, 2t is pi over 2. So we're talking about sine pi over 2, close the bracket, you find +1. So you find us there. And of course, sine, when t is pi over 2, then we can talk about 2t being pi, and then the sign of pi is obviously 0. So our graph moves like this. So you'll see the range openly. So the range of fx, is, or rather, y is greater than or equals to 1, -1, less than or equals to +1. You can see it. And I want to challenge everybody to use this equation and sketch your graph and let me see what you get. All right.